Could humanity build an Evangelion? And I'm not talking about the giant monster underneath. Even though I fully believe we could do it, all it would require is selective breeding between these two for a few thousand years and we're there. But I don't have the biological degree to tell you how and why this would happen. But I do have the engineering degree to tell you how to build a life-size Evangelion robot. Or at least I will. Eventually. In 3 years' time. But a lack of a degree has never stopped me explaining giant robots before, and it's not going to stop me now. So to begin the project, we need the exact size of the Evas. But this question leads us to a huge problem. Because, and I quote, scale was of very little importance when depicting the Evangelions. This means that the writers just change the size of the Evas whenever it suits them. I mean, look at this scene in End of Evangelion. If Unit 2 stood up, I think we can all agree it would still be under the water. Even if it jumped, it would still be very underwater, because it's 80 meters down. So why, in the next scene when it stands up, is the water only waist deep? It makes no sense! In one scene, the Eva looks 30 meters tall, and then in the very next scene, it looks 160 meters tall. This leaves us in a bit of a pickle, because I'm trying to figure out if humanity could build one of these, but I don't know how big we're gonna have to build. Now, I could take the high road and figure out the optimal size of an Eva by calculating the strength of metals, and seeing what the optimal Eva size would be for each metal, and how effective they would all be on the giant robot. Or, I could take the low road and just make the Evas the same size as the giant robots from my favorite movie. And you'll never guess which one I picked the movie option. And the robots in Pacific Rim are 79 meters tall, which is way more convenient than you would think. Because if you Google the height of an Evangelion, it says 80 meters tall. Let's go! Even though it's not official, my assumption was right. Let that be a lesson to you all out there. When given an easy road, drive it. And drive it fast. So now we got the height, the next thing we need is the weight. And for this one, I will not be using the Google, because I can actually use maths for this bit. Not that I want to, though. The Evangelions are essentially giant humans, so their weight proportions are the same as humans. So if we take the average human height and weight, then scale it up to the size of an Evangelion, then we'll have the weight. So the average man is 1.75 meters tall, or 5 foot 9 inches. And we know that the Evas are 80 meters tall, so we just divide 80 by 1.75, equaling 45.7142857. I know that's a long number, but we'll need it for later. Now to finish the equation, we just need the average person's weight. But that number's a little bit tricky, because weight changes a lot based on age. So do I go with the average global age at 30 and take the weight from there? Or do I go with the average weight of a fighting age male? It's a tough question. If you're an idiot, obviously the weight of an average 20-something, because that's around fighting age. And you would assume the Evangelions have the physique of a man around fighting age, or at least it would make sense if they did, because all these things do is fight. Why would they want to look like someone who's built like this? So the weight of the average age fighting male is 197.9 pounds. Or if you want to use a better unit, 89.76593. So to get the weight of an Eva, we need to times the weight by the difference in height between the Eva and the human. So 45 point whatever I said times 89 point also whatever I said equals 4,103.58537. But we're just going to round this to 0.585. You'll probably see why in a sec. Because this means that the total weight of the Eva is 4,103.585 tons. Just for the stupid people in the audience, I changed it to 0.585 because these digit points represent kilograms, and all the numbers after that represent grams. And I wanted to have kilograms shown and not grams, because I hate the gram. Subscribe. So now we have the total weight, we need to figure out the weight proportions. And since Evas are just giant humans, they have the same proportions as us. And right now I'm going to go through them, and it's going to be a lot of numbers, so just brace yourself. Skip to this timestamp if you really don't want to hear the numbers, because this is important, but it's really boring, and you can still understand the video without the numbers. So we got 7% mass in the head, weighing 287.25 tons, 43% mass in the torso, weighing 1,764.542 tons, 6% in the upper arms, weighing 246.254 tons, 3% in each individual upper arm, weighing 123.108 tons, 4% mass in the lower arms, being 164.143 tons, or 82.072 tons individually. The hands are 2% mass in total, being 82.072 tons together, and 41.036 tons on their own, making the total weight of both arms 492.430 tons, being 12% mass in total, and each individual arm is 6% mass in total, weighing 246.214 tons. Now onto the legs. The thighs take up a total mass of 24%, being 984.860 tons, or 12% mass individually, making them 492.403 tons each. The calves are 10% mass, making them 410.359 tons, and 5% individually, being 205.179 tons. And the feet are 4% mass, making them 164.143 tons, and 2% individually, making them 82.072 tons. tons. This makes the total mass of the legs 38% or 19% individually. And the legs weigh 1,559.362 tons, or individually they weigh 779.681 tons. Alright, you still there? I know that was a lot of numbers, but I'm proud that you stuck with me. Now we're going to move on to what they're made of, and then I'll tell you how possible it is to build one. If you Google what the armor they're wearing is made of, you get the simple answer, metallic plate. Great! That's really helpful. I had no idea they were made of metal. That was so useful. Thanks so much, Google. However, this is no matter. All that's going to happen is I'm going to use my brain, or what's left of it. I spend a lot of time on Instagram Reels, okay? And that stuff really rots your brain. But it's not rotten enough to forget that titanium is the strongest metal. So that's what I'm going to use to build this hypothetical Eva. Because of a few reasons. One, it's waterproof, which is a must. I mean, just look at how these things are stored. If it was made of a corrosive metal, this thing would melt away in 3 weeks tops. Two, titanium is super strong, so it's great for these giant machines of war, which is super important for Evas because all they do is fight. And even when they're fighting in the most favorable of circumstances, they still take a beating. And three, my final point, titanium is relatively light, so you can strap way more armor to the Eva. Like, if you were using something like steel to make the Eva, it would have to be 30% smaller to be the same weight as the titanium Eva. Or if you still wanted to build it out of steel, you would just have to put a lot less armor on it, which is not ideal. Now, I know what you're thinking. If titanium is so good, then why doesn't the army build all of their tanks out of it? And I'll tell you exactly why. Titanium is extremely expensive, but I don't think price really matters, both in this video and in Evangelion. In fact, I know it doesn't matter in this video. It's my video. So I'm going to make them out of titanium. And that means we have everything. We have their height, their weight proportions, and what they're made of. Now for the final question. Can we make one of these beasts move? No! God, no! Not even close! These things would collapse under their own weight long before they had the chance to move. Hell, the ground beneath them would collapse before they could move. If they even could move, which they definitely couldn't. Let me explain. First of all, the Evangelions wouldn't be able to stand just anywhere. We would need to have specially designed floors for them wherever we wanted them to go, because the ground pressure would be insane, putting around 20,000 newtons of force into the ground with each foot, or about 2,000 tons for each foot. And it gets even worse when they start walking, because instead of having 2 feet on the ground, it becomes 1, creating about 40,000 newtons of force and putting 4,000 tons of weight into that 1 foot. The only reason for such high ground pressure is because the entire weight of the Eva is being put through 2 feet. And relative to the weight of the Eva, 2 very tiny feet. Some buildings weigh many more times than this Eva concept does, but their pressure is being spread over thousands of square feet instead of just a few square feet, so their ground pressure is fine. And now that we've covered why this thing wouldn't even be able to walk about safely, I'm going to talk about the limits of titanium. Let me explain. Titanium is a metal, and like all metals, it has its limits. And if we built an Evangelion, this limit would be reached quicker than your limits when you take that old man's order. And then when you bring the food over to him, he decides that he changed his mind, but didn't decide to tell you that he changed his mind. And now he's talking to the manager about the lack of quality control in the hiring process. And you don't even want to work here, but you need money to run your car so you can travel to work so that you can afford to run your car so that you can travel to work so that you can afford to run your car so that you can travel to work so you can afford to run your car. I mean, I wouldn't know what that feels like, but I'm sure you do. Anyway, another issue is the amount of force required to lift its arms. It would be a ridiculous amount, probably similar to the force rockets need to leave Earth. That was a bit of an exaggeration, but you get my point. We don't have the technology to produce enough power to make it move, and we don't have the materials needed to support this thing. The stress of the titanium from the titanium above it would snap the titanium, and the compression from the titanium above the titanium would warp and bend it out of shape. The titanium would kill the titanium, and that's the current situation. But is it possible to build one of these in the future? No! Let's say hypothetically we had a metal strong enough to support the Eva's weight. The ground pressure would still make it unusable, unless you put it in the ocean, because then the buoyancy would make it a lot lighter. But if you've watched Evangelion, then you know that the Evas were not meant to operate underwater. So sadly, Evas will remain science fiction, unless this is all wrong. Well, I hope I am, as I've always been a big supporter of giant robots. After I finish my engineering degree, I'll come back to this topic again, and I'll hopefully laugh at how stupid and wrong my non-degree self was. But for the time being, I'm 99.999999999% sure that Evas are impossible. That's all for today. Thanks for watching, subscribe, and goodbye.